Let us look at infinite sequences and their boundedness. What exactly boundedness means, we will see. Now, we have already seen an infinite sequence is a sequence of numbers that goes on forever following a pattern. So we usually represent it like this, where a sub n is the nth term of the sequence. Now, an infinite sequence of real numbers is a function of n whose domain is the set of natural numbers and codomain is the set of real numbers. So we write this as a sub n is equal to f of n. Now to plot the sequence in a Cartesian coordinate system, we take the ordered pairs n comma f of n, where n is in the set of natural numbers. And these points must not be joined or connected in any way, since the domain is discrete. Just remember, two sequences a sub n and b sub n are equal if a sub n is equal to b sub n for all n. Here, a sub 1 is equal to b sub 1, a sub 2 equal to b sub 2, and so on. Now, if there exists m in real numbers such that a sub n is less than or equal to m for all n in the set of natural numbers, then we say that the sequence is bounded above by m. So here, none of the terms is greater than m. Now, m might appear anywhere in the sequence or it may not appear in the sequence. From a graphing perspective, y is equal to m is a horizontal line which is never crossed by any of the terms of the sequence, although terms may touch the line. They will never cross the line. So that was bounded above. Now, if there exists m in real numbers such that a sub n is greater than m for all n in natural numbers, then we say that the sequence is bounded below by lowercase m. So generally, lowercase m is used to show the bounded below and capital M is used for the bounded above. Now again, m might appear anywhere in the sequence or it may not appear in the sequence. A grasping perspective, again, y is equal to m is a horizontal line which is never crossed by any of the terms of the sequence, although terms may touch the line. Okay, now let's look at some examples to understand what is all this about. Any idea what this set of points represent? They represent the sequence a sub n is equal to n. That is, a sub 1 is 1, a sub 2 is 2, a sub 3 is 3, a sub 4 is 4. So our sequence is 1, 2, 3, 4. So here you can clearly see that it is bounded below by 1. None of the terms go below 1. And it is unbounded above. So as n goes to infinity, the term also goes to infinity. What about this? What does this represent? First term is 2, second term is 4, third term is 6. So this represents a sub n is equal to 2n. That is, list of all the even numbers. So you have 2, 4, 6, dot, dot. Now here again, it is bounded below by 2, unbounded above. Now what is this? When n is 1, a sub n is 1. When n is 2, a sub n is 3. When it is 3, it is 5. When it is 4, it is 7. So this is a sub n is equal to 2n minus 1, which is 1, 3, 5, 7. So basically all the odd numbers starting from 1. So here it is bounded below by 1 and it is unbounded above. Now what about this sequence? There is also a sequence. So here a sub n is equal to minus 1 to the power of n. So when n is 1, a sub n is minus 1. When it is 2, it is minus 1 to the power of 2, that is 1. So here the sequence goes minus 1, 1, minus 1, 1, minus 1, 1 and so on. So here it is bounded below by minus 1 and it is bounded above by 1. What about this sequence? Here you have when it is n is 1, a sub n is minus 1, 2, 2, 3, minus 3, 4, 4, 5, minus 5. So here the sequence is a sub n is equal to n times minus 1 to the power of n. So the sequence goes minus 1, 2, minus 3, 4, minus 5, 6 and so on. It is unbounded below because this is not the lower bound. Because there are other terms in the sequence which are lower than that. And same is the case here also. So unbounded above. Now this is a little bit trickier than that. It's not easy to visualize what the values are of the terms. So the sequence is a sub n is equal to 1 by n. So when it is n is 1, a sub n is 1. When it is 2, it is 1 by 2. When it is 3, it is 1 by 3. So the sequence goes like this: 1, 1 by 2, 1 by 3, 1 by 4 and so on. So here it is bounded below by 0, but 0 is not in the sequence. Why? Because as n goes to infinity, 1 by n goes to 0. It doesn't actually touch 0 and it is bounded above by 1. So here you notice that bounded above by 1, which is the highest point. Now here the function of n, that is a sub n, is equal to n plus minus 1 to the power of n. So we basically have, when n is 1, we have 1 plus, this is minus 1. So 1 minus 1 is 0. When it is 2, it is minus 1 square, that is 1. So 2 plus 1, 3. So here you notice it is oscillating. 0, it goes to 3, then comes down, then goes up, then comes down, and so on. Now here it is bounded below by 0. And 0 is actually there in the sequence. And it is unbounded above. Now let's look at this sequence. This is a sub n is equal to n by 2 square. So basically we have 1 by 2 square, 2 by 2 square, 3 by 2 square, 4 by 2 square, and so on. So after simplification, the terms are 1 by 4, comma 1, comma 9 by 4, comma 4, comma 25 by 4, and so on. Here, it is bounded below by 1 by 4, and it is unbounded above. Why so much focus on minus 1 to the power of n? In many of the examples, I use that. Now, the reason is that it may crop up in different forms. For example, cos n pi, the sequence it generates is the same as the one generated by minus 1 to the power of n. Similarly, sine of n pi plus pi by 2 is equal to minus 1 to the power of n. And pi by 4 plus n pi by 2 is equal to minus 1 to the power of n. I to the power of 2n is equal to minus 1 to the power of n. Here I is the imaginary number. I to the power of n square is equal to minus 1 to the power of n. E to the power of I pi n is equal to minus 1 to the power of n. 1 minus 2 n mod 2 is equal to minus 1 to the power of n. And because minus 1 to the power of n can appear in many different forms, that is why that focus was there. But the main concept that we looked at was the boundedness of infinite sequences, specifically upper bound and lower bound. So that was infinite sequences and their boundedness. Now, if you found this session helpful, please do like, share, and subscribe. Comments, suggestions are always welcome. Thanks for watching. See you in the next session. That's it for now.